Now let's continue. So in this specific video, we'll start to talk about two very important quantitative methods within inventory management process, which are called fixed order quantity model and also fixed time period model. So we will start from comparing these two models, okay, and try to figure out the key essence of each model and also the key difference of these two models, and try to understand basically in what circumstance for what type of products fixed order quantity model is more feasible, and in other circumstance, probably fixed time period model is more feasible. All right, before we jump into the technical details of each model. Now let's start. So first of all, for the fixed order quantity model, we also call it EOQ model or Q model, basically the same meaning here. All right, so EOQ represent economic order quantity. Basically, in this specific model, we would like to figure out what is the optimal order quantity amount that each time we will order, let's say from our supplier, that can basically minimize the total inventory cost. So that will be one of the most important questions that we would like to clarify within this specific model. All right. And then beside that question, okay, so we know that within fixed order quantity model, the order quantity amount that each time we order from our supplier is fixed. Okay, but when we should reorder some new inventory from our supplier, that's another very important question. We have to basically set up the reorder point, basically the reorder level that will trigger the reorder event, right? So this question we will also clarify. We will also have some equation to get the corresponding reorder level or record reorder point, okay? But before that, at least here, you already have some solid sense about this whole process, right? So basically, for example, we have some inventory within our warehouse, and when the market demand is realized, your inventory is going down because some of the inventory already becomes the sales product. All right. And once the inventory jump down to that reorder level, reorder point, then it will trigger, a new reorder event. Okay. That's why within the fixed order quantity model, we call it event trigger system. Okay. And obviously this will be a continuous review system because, when this inventory is going down, you probably need an employee to count, let's say the current inventory situation. Once the current inventory situation is below the reorder point, then it will trigger a new reorder event. Now let's move to the fixed time period model. Fixed time period model is also called P model. So different from the fixed order quantity model, fixed time period model is a periodic review system, which indicates that basically employee will not need to continuously review the inventory amount within the warehouse. They will only look at the inventory amount triggered by the interval time. For instance, they may only look at basically the inventory amount within their warehouse at the beginning of every month, or at the middle of every month, or at the end of every month. All right. So they won't actually continuously look at the inventory amount, for example, every day. So that's why we call it a periodic review system. Here, after we talk about fixed order quantity model and fixed time period model, I would like to point out a very important key difference between these two models conceptually. So within fixed order quantity model, as you can see, the order quantity that you will reorder each time within this whole dynamic process is fixed. All right. However, the time period between, let's say, two reorder events is a flexible amount. All right. However, on the other hand, within fixed time period model, the time period between reorder events is a fixed amount. The order quantity that each time you reorder, let's say from your supplier, is a flexible amount. So in short, fixed order quantity model, order quantity is fixed, the time period is flexible. However, within fixed time period model, the time period is fixed, the order quantity is flexible. That's the key difference here. Now, let's look at in what kind of circumstance fixed order quantity model itself is more feasible. However, on the other hand, in other circumstances, fixed time period model is more flexible. So first of all, as I just mentioned, within fixed order quantity model, it's a continuous monitoring process, and you probably need to recruit some employee to continuously record the inventory amounts within your warehouse. Each time when the inventory amount within your warehouse is lower than the reorder point, it will trigger the reorder event. You probably have to contact your supplier to reorder some new amount to your warehouse. Okay, so that's fixed order quantity model. However, different from fixed order quantity model, within a fixed time period model, you won't actually count your inventory amount all the time, right? You probably only review your current inventory amount as one specific period of time. So you may only look at your inventory amount at the beginning of every month or at the end of every month. Okay, so that's why we call this a periodic system. Okay, and due to this key characteristic difference, normally by using fixed order quantity model, the average inventory level within the warehouse can be smaller compared to the fixed time period model. The underlying reason is very intuitive, right? Because within the fixed order quantity model, the employee continuously monitor the inventory amount. Then the corresponding probability of having stock out situation is lower. That's why we can actually monitor a lower average inventory amount within our warehouse. And also we won't actually have risk to basically have the stock out situation. That's the main reason here why fixed order quantity model can have a lower average inventory amount compared to the inventory amount by using fixed time period model. All right. Also, fixed order quantity model is more favorable for those expensive items. Okay, another very important reason why we want to keep our inventory level small is because of the holding cost. All right, for those type of luxury items or expensive items, the inventory value for every unit is very high. Then of course we won't actually want to hold too many inventory within our warehouse, right? So that's why for those luxury or expensive items, normally the company will prefer using fixed order quantity model. Okay, they will recruit employee to count the specific number of inventory all the time. All right, and on the other hand, for those less expensive items, let's say the manufacturer of T-shirt, okay, they may more favorable of using fixed time period model. Okay, instead of continuously monitor the inventory amount all the time, they may only monitor inventory amounts periodically. And related to that, fixed order quantity model is more appropriate for those important items and also for those process that is more expensive to implement, okay, compared to using fixed time period model. That's actually quite intuitive. All right, now let's start to detailedly talk about fixed order quantity model. So fixed order quantity model, as I just mentioned, is a continuous review system, right? And there are two very important questions we would like to clarify by using fixed order quantity model. First of all, what is the optimal order quantity each time when we try to reorder? Okay, which we can basically minimize the total inventory cost. Okay, that's the first question. We call it EOQ amount. All right. Another very big question is that when we should reorder. Okay, when the inventory amount reach to what level it's time for us to reorder from our supplier. So these are two main questions that we would like to clarify within this specific model. Okay, we start from the easiest setup. Okay, here, as I show here, we have 5 assumptions, but in general, the assumption is quite simple. Basically, if we assume we have perfect market demand forecast, okay, we know exactly what will happen for market demand in the future. We know it's a little bit idealistic, but let's start from the the most simplest case. Okay, and then if we exactly know what is the lead time amount, okay, you may still remember what is the lead time. Lead time basically is representing the shipment time or transition time for, let's say, this order to ship from the supplier's factory to a warehouse. Okay, if we exactly know when this shipment will come to your warehouse after you contact your supplier, okay, then based on these two big assumptions, what is the best EOQ and when we should reorder? Here, I present this plot to simply better illustrate the inventory cycle by using fixed order quantity model, which is very straightforward and simple. Let's look at this. Suppose you have Q amount as inventory or within your retail store, all right? And you can imagine some of the customer walking to your retail store and buy some of the products, and that's why during this time, actually inventory is going down all the time, all right? And once the inventory reaches the reorder point showing here, okay? So basically at this moment, you probably need to contact your supplier to order some new amount from their factory back to your retail store, okay? But it doesn't mean that basically after you contact, those new amounts will automatically come to your retail store without any time. No, it probably will take some days, a few days or a few weeks, okay, to ship from their factory back to your retail store. and this is corresponding to lead time. And during this transition time, actually, your inventory within your retail store is still going down because although you already ordered it, but you haven't received it, right? Only after the lead time, okay? You see, when your inventory reaches to this minimum point, then the new amount comes and suddenly your new inventory will reaches this maximum level. Okay, here we assume the perfect market demand forecast and also the perfect lead time without any uncertainty. Okay, that's why you see this whole pattern is like this. Okay, your inventory is like a flow and it's always changing during this whole process. And within the fixed order quantity model, okay, what is the best order quantity, or we call it lot size, that we should basically order each time? That's a very important question. And we should set up our reorder plan at what point? That's another very important question we would like to clarify here. Now let's move to the technical detail of calculating EOQ, or we call it basically the optimal order quantity within the fixed order quantity model. Now, we all know that our final target is to basically get the minimum total inventory cost, right? And here, for inventory cost, we further incorporate two different types of inventory costs, which are inventory holding cost and also inventory ordering or setup cost. Okay, we detailedly compare different type of inventory within the last video. If you're still unclear about it, please look at the previous video related to inventory concept. All right. Now here, I basically list the conceptual equation related to annual holding cost and also annual ordering cost, which is very simple. As you can clearly see here, first of all, for the annual holding cost, it equals to the average cycle inventory times the unit holding cost. You may still remember what it means by average cycle inventory. Very simple. Average cycle inventory represents what is the average amount of inventory within my warehouse. We all know that basically the inventory management itself is a flow, all right? The inventory amount is always changing during this whole process. But if we want to basically measure what is the average inventory amount within our warehouse, we can basically use this average cycle inventory definition here. All right. And after we get some sense about basically on average how many inventory are within our warehouse currently, all right. And if we also know for every unit how much we need to pay in order to hold this inventory, then the multiplication between these two things will give us the annual inventory holding cost, for the average inventory amounts within our warehouse. Okay, that's actually very intuitive. On the other hand, for the annual ordering cost, it equals the number of orders in this year times the ordering cost, which is also very straightforward, right? So if we know that basically for every order, we need to pay this amount, okay? And if we also know the number of orders that we ordered in this year, we multiply this two, it will give us the total annual ordering cost, okay? And our total cost is simply the summation between annual inventory holding cost and annual ordering cost, okay? Here, I use the mathematical equation to express the total inventory cost, which is very straightforward. Which the key sense here is exactly the same as what I just mentioned. Let me briefly illustrate it, all right? The expression showing here is exactly reflecting, two different types of inventory cost. The first element is representing the total annual holding cost, and the second element actually is representing the total ordering or setup cost. Okay, let me illustrate each element. First of all, this is representing the total annual holding cost. Why? Remember, we have this plot, right? When we try to illustrate the key, idea of inventory cycle within fixed order quantity. We know that basically the maximum level of order inventory amount is Q. The minimum level is what? Is 0, basically, right? If we follow this basic assumption here. Later on, we will relax the assumption, but here, let's see, basically, you see the maximum level is at Q and the minimum level is at 0. So what is the average amount? You can already imagine that, right? So the average amount basically is at the middle, right? So what is the middle between Q and 0? It should be Q over 2. The average amount within the warehouse is Q over 2. That's it, all right? If we multiply H, what is H here? H actually represents for every unit of inventory, you need to incur this amount of cost to hold this specific inventory. So that's why if you simply multiply these two, that will give you the total annual holding cost for this average amount of inventory. Okay, so the second element is related to the annual total ordering cost. Why this can represent that amount? Very easy. D shown here basically represents the annual market demand. Suppose we exactly know that specific amount, D, all right? And Q represents lot size, still the lot size, the amount that we, each time when we reorder Q amount from our supplier, okay? So if you use D over Q, what it means? It represents how many times you need to order from your supplier, right? Since what you're doing here basically is just to try to fit for the total market demand, right? If the market demand is D showing here, you divide by Q, that will give you how many times I need to reorder from my supplier, okay? And suppose I tell you that each time you need to incur S amount for ordering this specific lot, all right? So that's why here, if you use these two things multiply with each other, that will give you the total setup cost or total ordering cost, okay? And if you simply sum up these two elements, that will give you the total cost, okay? Now, by having the equation of total inventory cost, let me ask you this question, all right? If I increase the lot size, okay, how the corresponding annual holding cost and also the annual ordering cost will change? Very simple, right? We know that basically Q here represents the lot size, all right? If I increase Q, then basically the corresponding annual holding cost for inventory will go up, right? Because Q is showing within the numerator. However, simultaneously, you see within the annual ordering cost expression, Q is showing within the denominator. If we increase Q amounts, actually the annual ordering cost will go down. This is actually very intuitive, right? Think about this. When you increase your lot size, actually will increase your annual holding cost. However, on the other hand, the annual ordering cost will go down. So that's a brief illustration about how to look at this, specific equation. Now, in order to find out the optimal order quantity level, then can minimize the total cost. Actually, it will require some theoretical derivation. Okay, we will use one mathematical tool, which is called first order condition, to get the optimal order quantity level. I will skip that part, all right, but will directly provide you guys the corresponding result, the optimal order quantity, EOQ amount, okay? And the expression is basically showing here. It's the square root of 2ds over h, okay? The expression showing here is very simple. As long as you understand the term within this specific equation, you can guess the optimal order quantity very easily, all right? Now, let's try to interpret the specific equation shown here. So D actually represents annual market demand, okay? Don't forget that, it's annual market demand, all right? S actually represents the setup cost, and H is basically representing the holding cost. So as long as you know the value of these three terms, you can simply plug into the specific equation to get the corresponding optimal order quantity level. We call it EOQ. That's it, okay? That's basically a lot size we would like to reorder each time when the inventory amount is below the reorder point, okay? After we calculate EOQ, then if we will also want to look at what is the time between orders, it's very easy, and exactly as I show here. You just directly use EOQ divided by D. That will give you the time between orders. But keep in mind, currently, the time unit is based on years, since this is talking about annual market demand realization right here. All right. So if you try to transfer to months or week or days, you basically just do some simple further calculation. You will get the corresponding amount. All right. Now, another very important thing that I would like to talk about is basically related to reorder point. Basically, this is representing when should I reorder. When the inventory amount is dropping to what level, we should reorder some new amount from the factory, for example, from our supplier. All right. Now, in the simple setup, R simply equals to D bar times L. Remember, we set reorder point as a positive amount instead of 0, simply because basically, even if we order some new amount from our factory, they cannot ship it to us automatically. It will need a few days or a few weeks to ship from their factory back to our retail store. Okay, we call it lead time. And during this lead time, some new customer may show up to a retail store and try to buy some product. That's why you still need some inventory to basically prepare that kind of the situation. That's why reorder point here simply equals to D bar times L, basically to cover the market demand realization during the lead time. The D bar showing here can be viewed as the average, for example, daily market demand, and the corresponding lead time will be the number of days that will actually ship from the factory back to your warehouse. Okay, so the unit doesn't have to be days, it can be based on weeks. Okay, but as long as the corresponding unit for D bar and L is consistent with each other, that's good enough. Now let's use a quick example to illustrate the key sense of fixed order quantity model. As you can clearly see here, suppose a museum of natural history opened a gift shop which operates 52 weeks per year. Okay, the top selling SKU is a bird feeder. Sales are 18 units per week and the supplier charges $60 per unit. We know the cost of placing order with supplier is $45 and the annual holding cost is 25% of a feeder's value. Okay, suppose we also know the lead time of the shipment for each order is 2 weeks. Okay, if we want to calculate the EOQ, the optimal order quantity, and also what is the corresponding total annual cycle inventory cost, how we do it, okay, what is the reorder point, and how frequently we should order here, all right? Now, here I simply list the corresponding steps, okay, which is very standard. Now, before we can calculate the EOQ, all right, we need to figure out what is the correct amount of D, S, and also H. Okay, we know D is representing annual market demand realization. All right, here from the information context, we know that sales are 18 units per week. Okay, and normally in every year we have 52 weeks. So that's why here you see the annual market demand basically is 18 times 52. That will give you 936 units per year, basically. All right, so from this equation, you already know what is the annual market demand, 936 units. Okay, now D, you already know. Okay, how about S? If you go back to the information context, you know that the cost of placing every order with the supplier is $45. So basically, you already directly tell you S equals to 45. You don't need to worry about it. All right. And another one is H within the EOQ equation, right? What does H represent? H represents the annual holding cost. How we calculate the annual holding cost? Very easy. Here, we know the annual holding cost is 25% of feeder's value. What is the feeder's value here? Okay, the feeder's value, basically, you see the supplier charges $60 per unit. Okay, so the annual holding cost is basically 25% of this $60 per unit. Okay, that's why here, if you look at the equation to calculate annual holding cost for every specific inventory, 0.25 times 60 will give you $15. So basically, if I want to hold one specific inventory, the annual holding cost for that specific inventory is $15. Okay, and then after you know D, S, and H, right, you simply plug into this specific equation, okay, properly, and then you can simply get the EOQ amount. Okay, we take the integer value, that's why this is 75 units. Okay, because the order quantity amount has to be an integer amount instead of decimal point amount. Okay, so that's why normally we'll run up to the corresponding integer amount. So after you calculate your EOQ amount, okay, then if we want to calculate the corresponding total annual inventory cost, it'll be very straightforward, right? We already know that TC, the total inventory cost, equals to Q over 2 times H plus D over Q times S. Okay, so after you know the EOQ amount, you simply take this amount back into this equation to represent the Q amount. Okay, and here we already know what is the D value, what is the H value, and also what is S value. You also plug in this corresponding value into this corresponding equation. You will see this whole process of calculating the total inventory cost. Okay, you can definitely check, you know, by using some other Q amount. Instead of 75, you may use, for example, 80, for example, 60. You will find out that the corresponding total cost will be higher than this amount. Okay, showing here, simply because the EOQ amounts will already ensure that the corresponding total cost is the minimized inventory total cost. Okay, you can definitely double check it. Okay, that's actually a very nice process. Now, besides that, the reorder point here, the calculation is also very standard. The reorder point R level equals to D bar times L. All right, here actually from the information context, we already know that basically the average sales will be 18 units per week. Okay, and since we already perfectly know that the lead time of this whole shipment, right, is 2 weeks. So that's why here, basically, the D bar can be basically 18 units per week, and lead time is 2 weeks. The corresponding reorder point is 36 units. Okay, how we interpret, EOQ together with the reorder point, very simple. Basically, each time when your inventory amount is below 36 units, okay, then it will trigger the event of reordering some new amount from your supplier. Okay, and the specific amount that you will reorder from your supplier will be this EOQ amount, which is 75 units, because this units can help me minimize the total inventory cost. Okay, now, besides that, of course, if we also want to calculate what is the specific time between two orders, you simply use EOQ, divide by the corresponding annual market demand. Okay, that will give you the specific time. Since this annual demand, the corresponding unit will be year, but it will be very easy for us to transfer this specific value to the corresponding, for example, based on months value, based on weeks value, or based on days value. Okay, so if we based on day, you can see that basically the TBO here is 29.25, which indicates that between two specific order, the time period is 29.25 days, which is basically very close to 1 month. Okay, now here I basically just list of manager insights related to EOQ, how different parameter change will impact EOQ. Very simple. Let's use our intuition to understand the how the parameter change will impact EOQ. Okay, first of all, when the market demand actually increases, okay, the EOQ will increase or decrease. It should increase, right? Because when market demand increase, basically you probably need more inventory to prepare the better market demand, right? So that's why you see EOQ will also go up. Okay, mathematically, since D is actually showing within the numerator, and when D goes up, therefore EOQ will go up. Okay, and similarly, if you look at the ordering cost, when ordering costs go up, then your EOQ amount normally will also go up. Why? Because managerially, right, when ordering costs go up, you do not actually want to order too many times within this whole process. So that's why your EOQ amount will go up. Okay, and on the other hand, of course, when ordering cost is going down, then your EOQ amount will also go down. Okay, however, if we move to the holding cost perspective, we see that basically H is showing within a denominator. Okay, managerially, what it means, it basically tells you that when holding cost goes up, right, intuitively, we know that we don't actually want to hold too many inventory within our warehouse because it will incur more cost. So that's why the EOQ will go down, okay? Which indicates that basically when holding cost goes up, the corresponding EOQ will go down. Or oppositely, when holding costs go down, your EOQ amount will go up. So they're basically changing at the opposite direction, okay? So that would be a very simple sensitivity analysis related to how these different parameters will impact EOQ.